Friends, in this question, it says the distance traveled by a particle from a fixed point is given as a solution. The distance is given as s equals t cubed minus t squared minus t plus 5 in centimeter. We should find the minimum distance that the particle can cover from the fixed point. Okay? Now, if you look at this equation representing distance, it is going to give us a curve if plotted on a graph, and the minimum distance of this curve is the distance at which the rate of change in distance is equal to 0. That is when there is no rate of change in distance. What I mean is the rate of change in distance is change in distance over change in time. When it is equal to 0, you have the time at which this thing happens. If you substitute it here, whatever distance it gives you is the minimum distance. Okay, so that is what we are going to do. First of all, we are going to differentiate this. So if you differentiate x with respect, if you differentiate s with respect to t, it will be equal to this 3 times t will give us 3t. 3 minus 1 is 2. 2 times minus 1 is minus 2t. 2 minus 1 is 1. Then minus 1. This constant will go when we differentiate. And we said that this, the s over the t is going to be equal to 0. So we are going to equate 3t squared minus 2t minus 1 to 0. Then find the values of t, that the time at which the distance is minimum. So this is a quadratic equation now. So we are going to solve by factorization if possible. We can use 3t squared minus 3t minus t plus t. Minus 3t plus t will give us minus 2t. And minus 3t times t will give us minus 3t squared. So this is correct. Minus 1 equals 0. So when we pair them in twos, the common factor of this 2 is 3t. So we are going to have 3t factored out here. We are left with t. When you remove 3t here, you are left with t. If you remove 3t from here, you are left with 1. And I said that once you have this in factorization, once you have gotten the first bracket, still use the first bracket as the second. Instead of looking for a common factor in the other two, just use what you used as the first bracket to be the second, and then use this t to divide whatever is the third term here, and whatever you get comes out here. So this t divided this t will give us 1. So what we have here is plus 1. Okay, equals 0. So having done that, you have a common term in the bracket. So we bring one of it, and then the one outside the bracket will form the second bracket, 3t plus 1. That's equal to 0. Okay, so that means that t minus 1 is equal to 0. 3t plus 1 is equal to 0. Here t is equal to 1, and here t is equal to minus 1 over 3 if you make t subject of the formula here. But you know time cannot be negative, so this is the one we are going to use. So at t is equal to 1, that is where we have the minimum point. Okay, that's where you have the minimum point. Okay, then we are going to substitute it to get the minimum distance. So at that point, s is equal to 1 raised to power 3 minus 1 raised to power 2 minus 1 from here, then plus 5. That will give us what? 1 raised to power 3 is 1, minus 1 raised to power 2 is 1, they will go. Minus 1 plus 5 will give us 4. So the distance at which the minimum distance is 4 centimeter. Okay, that's the minimum distance that the particle can cover from that fixed point. See you in our next class.